Gas and Law by Mackenzie and Kate.
There are 6 objectives. The first objective is that you will be able to give characteristics of a gas, be able to learn how gases are compressed and diffused, be able to learn how gases exert pressure, learn what units and variables are given for measuring a gas, learn what kPa, ATM, and mmHg are and how they are used, and the last objective is that you will be able to learn about atmospheric pressure and what the standard condition to measure gases are.
What are the characteristics of gases? Gases are composed of a large number of particles that behave like hard, spherical objects in a state of constant, random motion. These particles move in a straight line until they collide with another particle or the walls of the container. These particles are much smaller than the distance between particles. Most of the volume of a gas is therefore empty space. There is no force of attraction between gas particles or between the particles and the walls of the container. Collisions between gas particles or collisions with the walls of the container are perfectly elastic. None of the energy of a gas particle is lost when it collides with another particle or with the walls of the container. The average kinetic energy of a collection of gas particles depends on the temperature of the gas and nothing else.
How are gases compressed and diffused? Gases are compressible because they are less dense than other states of matter and have fewer atoms or molecules per unit of volume. Because there is more space between the molecules, it is easy to compress the gas into a smaller space. Initial pressure and temperature of a gas determine how compressible it is. Compressing a gas makes it more dense. Although there is a limit to how much any given gas can be compressed, in general, doubling the pressure on a gas decreases its volume by 50%. Diffusion is faster at higher temperatures because the gas molecules have greater kinetic energy. Effusion refers to the movement of gas particles through a small hole. Graham's law states that the diffusion rate of a gas is inversely proportional to the square root of the mass of its particles. How do gases exert pressure? Gas exert pressure on the container in which it is contained because the molecules of the gas are constantly colliding with the container and exerting pressure.
What is gas in terms of amount? What variable is used? Amount of substance is a standards-defined quantity that measures the size of an ensemble of elementary entities, such as atoms, molecules, electrons, and other particles. It is sometimes referred to as a chemical amount. The International System of Units, SI, defines the amount of substance to be proportional to the number of elementary entities present. The SI unit for amount of substance is the mole.
How is volume of a gas measured, in what units, and what variable is used? Displaced fluid is the method that can be used to calculate the volume of a gas. The volume of fluid displaced would equal the volume of the gas. You can use a gas syringe, which is a laboratory instrument that can be used to withdraw a certain volume of gas from a closed system or to measure the volume of a gas from a chemical reaction. You can use a spirometer. It measures the volume of air coming into and being expelled out of your lungs, which is called tidal volume. Or you can trap the gas. You can use a balloon to trap the gas coming from a reaction. Then calculate the volume of the sphere. Natural gas is measured in cubic feet, while gasoline is solid at the pump in gallons. Because of the difference in the amount of energy produced from various energy sources and the differences in commercial measurements, comparing two energy sources requires that they both be measured in terms of energy units. British thermal units used when comparing energy sources. And when the generalized variable of amount in moles is discussed, the letter N is used as the symbol.
How is temperature always expressed and how do you convert to Kelvin? Temperature is an objective comparative measurement of hot or cold. Temperature is expressed through Fahrenheit and Celsius. Kelvin is equal to Celsius plus 273.15. The variables for Fahrenheit and Celsius are F and C.
What is meant by standard pressure and what standard pressure is used for ATM, kPa, and mmHg? A pressure at which standardized measurements may be made equal to 105 pascals or 1 atmosphere. 1 ATM equals 760 torr, which equals 760 mmHg, which equals 101.3 325 kPa.
What is atmospheric pressure? What are the standard conditions to measure gases? Atmospheric pressure is the pressure exerted by the weight of the atmosphere. This is about 14.7 pounds per square inch. Many professionals and scientists using the metric system of units define the standard reference conditions of temperature and pressure for expressing gas and volume.
Boyle's law. Boyle's law states that at constant temperature for a fixed mass, the absolute pressure and the volume of a gas are inversely proportional. The law can also be stated in a slightly different manner, that the product of absolute pressure and volume is always constant. Practice problems. Number 1. A container holds 500 milliliters of CO2 at 20 degrees Celsius and 742 torr. What will be the volume of the CO2 if the pressure is increased to 795 torr? Charles' law. Charles' law, also known as the law of volumes, is an experimental gas law that describes how gases tend to expand when heated. A modern statement of Charles' law is when the pressure on a sample of a dry gas is held constant, the Kelvin temperature and the volume will be directly related. Practice problems. Number 2. A sample of helium has a volume of 521 dm3 at a pressure of 75 centimeters Hg and a temperature of 18 degrees Celsius. When the temperature is increased to 23 degrees Celsius, what is the volume of the helium? Combined gas law. When we put Boyle's law, Charles' law, and Guy-Lussac's law together, we come up with the combined gas law, which shows that pressure is inversely proportional to volume, or higher volume equals lower pressure. Pressure is directly proportional to temperature, or higher temperature equals higher pressure. Practice problems. Number 3. The initial temperature of 1 liter sample of argon is 20 degrees Celsius. The pressure is decreased from 720 mmHg to 360 mmHg, and the volume increases to 2.14 liters. What was the change in temperature of the argon? Ideal gas law. An ideal gas law is defined as one in which all collisions between atoms or molecules are perfectly elastic and in which there are no intermolecular attractive forces. One can visualize it as a collection of perfectly hard spheres which collide but which otherwise do not interact with each other. In such a gas, all the internal energy is in the form of kinetic energy, and any change in internal energy is accompanied by a change in temperature. Practice problems. Number 4. A volume of 26.5 milliliters of nitrogen gas was collected in a tube at a temperature of 17 degrees Celsius and a pressure of 737 mmHg. The next day, the volume of the nitrogen was 27.1 milliliters, with the barometer still reading 737 mmHg. What was the temperature on the second day? Guy-Lussac's law. The law of combining volumes states that when gases react together to form other gases, and when all volumes are measured at the same temperature and pressure, the ratio between the volumes of the reactant gases and the gaseous products can be expressed in simple whole numbers. Practice problem number 5. A 30-liter sample of nitrogen inside a rigid metal container at 20 degrees Celsius is placed inside an oven whose temperature is 50 degrees Celsius. The pressure inside the container at 20 degrees Celsius was at 3 atm. What is the pressure of the nitrogen after its temperature is increased? Recap. Gases are less dense than any other states of matter and have fewer atoms or molecules per unit of volume. Diffusion is faster at higher temperatures because the gas molecules have greater kinetic energy. Gases use mole, and it uses the letter N. Kelvin is equal to Celsius plus 273.15. 1 atm equals 760 torr, which equals 760 mmHg, which equals 101.325 kPa. Atmospheric pressure is the pressure exerted by the weight of the atmosphere. This is about 14.7 pounds per square inch. Boyle's law states that at constant temperature for a fixed mass, the absolute pressure and the volume of a gas are inversely proportional. Charles' law is an experimental gas law that describes how gases tend to expand when heated. Combined gas law is Boyle's law, Charles' law, and Guy-Lussac's law together. Higher volume equals lower pressure, higher temperature equals higher pressure. An ideal gas is defined as one in which all collisions between atoms or molecules are perfectly elastic and in which there are no intermolecular attractive forces. Guy-Lussac's law is the law of combining volumes. Gases react together to form other gases. All volumes are measured out at the same temperature and pressure. The ratio of volumes to reactant gases and the gaseous products can be expressed in simple whole numbers.